In this video, you are going to learn how to combine two datasets using a family of join functions from the dplyr package. There are many cases in which you might like to combine a dataset you have with a related dataset that has complementary information. For example, say you have a data frame that contains happiness scores for each country, and there's another data frame that contains information on mean life expectancy. As long as there is at least one variable in common between the two datasets, say country name in this example, you can use one of a few join functions to combine these two datasets. The two example datasets we will be combining are called happy and happy join. This table here shows the information that the data frame happy contains. And the second table shows the information that happy join contains. You can see that it only has two columns, one of which, country name, is in common with the happy data frame. And this is important. We can also see that the two data frames are of unequal length. And this will help us illustrate why we might want to use different join functions. So here's an animation by the data scientist Garrick Aidenbury. We can see that the syntax for the left join is very simple. It's just the left join function containing the names of the data frames to be joined separated by a comma. If we look at this animation, we see that X and Y are both data frames that contain just two columns. X is the data frame on the left and Y is the data frame on the right. They both have one column in common, the column with the numbers. And it's this column that is used to join the two data frames. Doing the left join produces a new data frame that has three columns. The column that is in common for the two input data frames, and the other two columns that are different. We also see that all the rows from data frame X are retained. However, in the case of data frame Y, only those rows that have a match in the join column are kept. So in this case, that's just the first two rows of Y. Why might we want to do this? As a reminder, here's the code for our left join. When we run this, we see that the resulting data frame looks a lot like the happy data frame, but we now have an additional variable, healthy life expectancy, which could be useful information we might use later on. Note that since there was no life expectancy data for the country Spain in the happy join data frame, we get an NA in the healthy life expectancy column for Spain. We can think of the next join function, the right join, as doing the opposite of the left join. We first note that the syntax is the same, except we type right join instead of left join. In this case, all the rows of Y are kept, and only rows from X with matching values in the join column are retained. And remember that the column we are using to join is the one with the numbers. So why the need for another join? Let's take a look at an example to see why. The syntax is the same as for the left join, except we type right instead of left. Now we see that this produces a data frame that has all the countries that are in the data frame happy_join. Since Spain is not in this data frame, it's been dropped. So in this case, a right join would be useful if we only wanted to look at countries for which we had healthy life expectancy data. The third type of join we will look at is called the inner join, and is in some ways the simplest join we will be looking at. We can see that the inner join only keeps the rows for which there are matching values in the join column. Why use this? We take a look at another simple example, again noticing the syntactical similarity to the previous two join functions. And the resulting data frame is one that contains only countries that are in both original data frames. In this specific case, this has the nice effect of producing a data frame that contains no missing values, which again might be important if we were doing some kind of statistical modeling or machine learning where missing values could be problematic. And finally, we have the full join. As you can see, this join is the most complete one, and keeps all the information from both data frames. Again, we see that the code is similar to the previous joins. And if we take a look at the output, we see that we have combined both original data frames and retained all the information. So this is a useful function if it's important that you don't discard any information as you perform your data wrangling. So there you go. You've now learned some common ways of combining datasets in R.